Let's do a definite integral involving integration by parts. So again, if we're doing a definite integral, it will everything else will be as normal. I first need to figure out what is the antiderivative function before I do anything. And again, here we want to use integration by parts. And again, we might not necessarily know right away. Should I use U sub? Should I use IBP? Sometimes I might call integration by parts IBP, by the way. That's just, shorthand. But here, let's, again, if we're following the rule LIATE, ln is always a high choice for what we want u to be. So if we set u to be the natural log of y, and this one we're using y instead of x, but same difference, then that would leave du to be 1 over y dy. And then if ln y is our choice for u, then dv would have to be everything else in the integral. So that would leave us with 1 over the square root of y dy, which is kind of like everything else in the integrand. And we could write that as y to the minus 1/2 power, just again, to make it easier on ourselves to integrate, because I always need to integrate dv to solve v. And if dv is y to the minus 1/2 power v, I will need to use the power rule. So adding 1 to negative 1/2 would give me positive 1/2, and dropping the reciprocal would be 2. So I would have v is 2 times the square root of y, depending on how I want to write that. And now I should be set to use the integration by parts formula. So again, my original integral was u dv, and that's always equal to, integral of u dv, that should always be equal to u times v. So basically I'd have this times this. I'll go ahead and write that as 2 times the square root of y ln of y. So uv minus integral v du. And for v, this time I'll go ahead and write it as y to the 1/2 power, because it'll be easier to integrate in that form. And then it's going to be v times du. So that would be v times 1 over y dy. And again, we would have our boundaries of integration on this part. It would be a direct evaluation. And on the integrand, or on the integral symbol, we would need to keep our boundaries of integration there. And again, as I suggest, go ahead and solving this one before I plug it in, because I'm going to need to do it eventually anyways. And so here, y to the 1/2 divided by y, this is the same as y to the minus 1 power. So those 1/2 minus 1 would just make y to the negative 1/2 power. And I could pull that 2 out front. So cleaning that up a little bit, that would just simplify to y to the negative 1/2 power. And actually it ends up being the exact same antiderivative that I just solved. So we'd have 2 root y ln y. And then the antiderivative of 2 times y to the minus 1/2, well, again, I would add 1 and drop the reciprocal. So I'm going to end up with 1/2, positive 1/2, and I drop a 2. So this is going to be negative 4 y to the positive 1/2. Or again, y to the positive 1/2 is just the square root of y. So doing a couple simplification steps all at once there. But what I end up with is 2 root y times the natural log of y minus 4 root y. And now that I would generally recommend simplifying it as much as possible before I have to plug it in. But now, after I finish, now I can go ahead and plug in 9 and 4 and take the difference. And also, unlike u substitution, we don't want to be changing the variables when we're using integration by parts, because we're not actually doing a substitution. We're not actually changing variables. We're just using u and v as a formula to help use the structure. So in that way, it's a little different in my mind than u substitution. But anyways, if we were to plug in 9 here, I would get 2 times root 9 would be 2 times 3 would be 6 times the natural log of 9. And this would be minus 4 times 3, which is 12. And then I need to take away the result of plugging 4 in. If I plug in 4, I'd have 2 times 2 is 4 times the natural log of 4. And then minus 4 times 2 is minus 8. And I could clean all this up, because this would leave me with 6 ln 9 minus 4 ln 4. And then minus 12 plus 8 would be minus 4. And there are ways I could clean this up using log laws and so forth, but I think that's good enough just to leave it as that. And, I could write as a decimal, whatever else, but, the main thing I wanted to cover in this video is how do definite integrals change, and at the end of the day, it's pretty much the same idea. Just solve the integral, then plug them in later would be my recommendation.